What's up, Warriors? Coming to you on a Friday night. Just want to talk to you about something real quick. So, when we've done population proportion hypothesis tests, we've used the z-stat of the sample proportion minus p-pop over the square root of 1 minus p-pop times p-pop over the square root of n, or all that under the square root. This is a formula we've used. All has been good in the hood. And so when you go into Pearson, I encourage you to use this formula. If you do make a mistake in Pearson, Pearson is going to slip one in here and say, if you ask for help, that you ought to use what appears to be a different formula. Looks something like this. And when Pearson says that, you may say, well, what the heck? Dr. Shatskin betrayed me. He never taught me this formula before, doesn't know what he's doing. That may be the case some of the time, but not this time. I do not teach this formula because it's overly complicated, in my opinion. The other reason I don't teach this formula is because these formulas are the same. That's right. They don't appear to be the same, but they are the same. They're just written a different way. This formula down here is expressed not in terms of P, the sample proportion, but in terms of X, the characteristic of interest. Okay, so you don't find P anywhere in here because it's been worked out. All right, we know that P equals X divided by N. So you got to remember that this X down here is not a sample mean or anything like that. It's a characteristic of interest. If you still don't believe me that these formulas are the same, I will show you. So the way that we get from this formula to this formula is by multiplying this formula here by n over n. Now, why we would want to do that, I have no earthly idea, but that's how we do that. And so you might say, well, how do we get to that? Okay, well, let's take this top half. And let's just work the top half first. So when we multiply n times p minus t, we get, n times p minus the p-pop. We get that. Okay, that is also equal to x over n minus p-pop times n. Okay, because sample proportion P is equal to x over n. Now, once we take that n inside the parentheses here, what we have left is those n's cancel out. So we have x, and then we have sample size times p-pop, which is what we have down here. Okay, so that's how we get the numerator. Now, how we get the denominator is a little bit more complicated to go from this to this. All right, so the main thing is, how do we multiply n times a square root of something? Okay, well, it's kind of sneaky the way we do this mathematically, but if we think about this, n is really equal to the square root of n squared. When we see this, this seems awfully redundant. We would never write it this way, But to sneak it inside here, we're going to do that. So n times this whole mess is the same as, let me just draw a little line here, saying that 1 minus p pop times p pop over n times n is the same thing as multiplying that whole thing by that. And this is the same thing as getting that underneath there. So we're going to just slip it underneath that house. Come on in, have a little party. Like that. See how sneaky that was? And then, well, that over that takes off that and takes away that. And then we're just going to multiply these two. So it turns out to be the square root of n times p pop. We just scoot it on over times 1 minus p pop. And PEMDAS, our old Jackson Street friend PEMDAS, supports us doing that. So that is how we get this denominator over here. And this is how we get this numerator over here. So the bottom line is, have no fear. If Pearson comes back and tells you to use this formula, and you say, I've never seen that formula before, stick to your guns, use the formula that we used in class, or use this formula. You just got to know that X is the characteristic of interest. Either way, it's the same formula. I don't teach this because it looks complicated to me, or excuse me, I don't teach this one because it looks complicated to me, and I fear that it looks complicated to you. And again, that would be like me using the wrong end of the magnet to get something or to attract something. It's just pushing the other thing away. Yeah, it doesn't make any sense. Am I going to ask you to derive this formula to this form? No. No. It was hard enough for me to figure out how to do it. Not that you can't, but I just don't see the utility in it. Do I care about what formula you use when you're on an exam? Of course I don't. Pick your poison. Use what's comfortable to you. If now that you've seen this, you like rolling with it, just make sure you get some reps in, you validate it for you, and you know what it is. If you don't like this, never want to see it again, then just have faith that when Pearson says, hey, you ought to use this, that you could use this the same way. Either way, it's like any other tool. You got to know the components of the tool and where they go and what they mean and what the tool is supposed to do. So, with that, hopefully you enjoyed that video. I enjoyed figuring out how to do all this mumbo jumbo. And with that, stay strong and warrior on.